So today we are going to cover sections 11, 12, and 13, dividing decimals, converting from fraction to decimal or vice versa, order of operations, square roots, and the ever famous Pythagorean theorem. So we will begin with the division of decimals. So if I were to have, let's say, 34 hundredths, and I'm going to divide that into 2 and 176 thousandths. So when we do a division of decimals, write down your problem as you see it. What we're going to do with the decimal is, if in the divisor, if you have a decimal point, we want this to read as a whole number. So I would need to move my decimal 2 places to the right. So if I move it here 2 places to the right, under the symbol for division, I'm going to move it 2 places to the right here. Once I place it here, I'm then going to put it also up on the line for where my answer goes. So I have moved my decimal underneath the same number of places as it took to make my divisor a whole number. Then your process is just regular division. So what I have here is 34. It won't go into 21, so it's going to go into 217. It would go 6 times. 6 times 4 is going to give us 24. 6 times 3 is 18, plus 2 gives me 20. So now I'm going to subtract 204 from 217. That would leave me with 13. I would then bring down the 6. 34 goes into 136 4 times. 4 times 4 is 16. 4 times 3 is 12. 12 plus 1 gives me 13. And in this case, I do not have a remainder. So let's do another example. Let's say on this example, we have 4 hundredths being divided into 112 thousandths. The first thing I'm going to do is move my decimal. Here, I would have to go 2 places to the right to move my decimal. So in my problem, I'm going to move it 2 places to the right. My decimal would go here and then place it up above on your answer line. 4 goes into 11. How many times? 3 times 4 would be 12. That would be too large. So let's do 2. 2 times 4 will give us 8. When we subtract, we get 3. We then bring down the 2. 4 goes into 32 8 times. 8 times 4 is 32. And when we subtract, there is nothing left. And when you're working with and doing a division problem, you might find, and I'm going to give us an example of something such as this, that you might have to add more zeros. If we have, let's say, 54 and 23 hundredths divided by 100. What we're going to do is the denominator is going into the numerator. Remember, this is the numerator, this is the denominator. So what we're being divided into 54 and 23 hundredths. Now for this problem, if you will notice, this is a whole number 100. So I don't have to move the decimal anywhere. The decimal here is going to be in the same location up above. So as I do my division here, 100 does not go into 54, but it would go into 542. It would go 5 times. 5 times 100 is 500. When we subtract, we have 42 left. I would then need to bring down my 3. 100 goes into 423 4 times. 4 times 100 is 400. Subtract, and I have 23 left. Now notice, I'm not going to take a decimal answer and then blend and put a fraction along with the decimal. What I'm going to have to do here is I'm going to have to add an extra 0. So let me extend my line. When I need to bring something down, there is not a number there, so I add a 0, and this now becomes 230. 100 goes into 230 2 times. 2 times 100 is 200. Subtract, I have 30 left. Okay, 100 doesn't go into 30. Add another 0, bring it down. So now 100 into 300 goes 3 times. 3 times 100 is 300. And then I have a remainder of 0. So when you are working with decimal values, you're going to find that you may have to add zeros to continue doing your division. Now, something that's also going to happen with decimals from time to time is you might have a repeating decimal. Let me show you what that would look like. If you were to have the fraction, say 1/3, you would divide 3 into 1. 3 doesn't go into 1. So we add a decimal and a 0. The decimal goes up above here. 3 goes into 10 3 times. 3 times 3 is 9. When you subtract, you've got 1 left over. Okay, I have nothing to bring down, so I'm going to add a 0. 3 into 10 goes 3 times. 3 times 3 is 9. Subtract, we have 1 left over. Again, I'm going to extend, add another 0, bring it down. 3 goes into 10 3 times. 3 times 3, I've got 1 left over. So what you should see is a pattern here. 3 times 3 is 9. When you subtract, you've got 1. When this continues on and on, your answer would be 0.3, and you draw a line above what is repeating. Sometimes they may ask you to round to a certain place value, but there will be occasions where they're going to ask and see that you can determine what is a repeating decimal, and you may need to do so. Sometimes if this was 1 digit repeating, you might have something that's 2 digits repeating. It might be a 0.727272, and you would draw a line over the 72 if that's going to be what continues to repeat. You will have word problems where you're going to be doing some application problems, averaging test scores perhaps, finding the area or the cost of something per gallon, what kind of change you might get back. So you're going to have applications working with the division of decimals also. As we move into section 12, we're going to change fractions to decimals. So to change fractions to decimals, we have a fraction. You're going to divide the denominator into the numerator. So if we were to have, let's say, the fraction 3/8, it's going to be what we just did a moment ago. We're going to take 8 and divide it into 3. It will not go, so we add a decimal and a 0. Put the decimal in your answer. 8 will go into 30 3 times. 3 times 8 is 24. When you subtract, you have 6. We're going to add a 0, bring it down. 8 goes into 60 7 times. 7 times 8 would give us 56. Subtract, we have a 4. Add a 0, bring it down. 8 goes into 40 5 times. 5 times 8 is 40. And after we added a couple of zeros, we see this one divided out evenly, and we were able to stop. So that's one way we can go about doing that. If you're using your calculator, you're just going to do 3 divided by 8, press enter, and then there you go. You've got your 0.375 or 375 thousandths. If you have a mixed number, let's say we have 7 and 1/2. If we want to convert that, first we would convert this back into an improper fraction. 7 times 2 is 14, and 14 plus 1 is 15 over 2. So we would divide 2 into 15. 2 goes into 15 7 times. 7 times 2 is 14. Subtract 1 left. Now, since we need to continue, we then have to add the decimal in a 0, bring it down, add the decimal up here in our answer. 2 goes into 10 5 times. 5 times 2 is 10. And then here we have subtracted out to 0. That would be our solution. When we are doing a comparison, if we're doing a comparison of numbers, let's say if we're comparing the fraction 1/8, and we're going to compare that to 122 thousandths. If we're going to compare, you want to take the fraction and change it to a decimal. You can go through the process longhand we did a moment ago. I recommend just do your 1 divided by 8. That's going to give you 0 and then 125. So 0.125. We're comparing 122 thousandths. When you're comparing, notice the first 2 digits are the same for both. It will be this third digit that determines which is larger. The 5 is larger than the 2. So your fraction 1/8 is going to be larger than 122 thousandths. So with this part, convert your fractions to decimals and then just compare the place values of the decimal digits. In section 13, we are looking at square roots. When we look at square roots, what we have seen before, we have worked with square roots that were a perfect root. For example, we took the square root of 100, and that would give us a solution of 10. The way we would do that, remember, is second, and then this key, x squared, activates the square root, and you type in your value here, the 100, and it comes out evenly as a whole number. The reason it does is because the square root of 100, you have 10 times 10, you have a pair of tens of the same number that comes out from underneath. However, not everything is going to be a perfect square root. Sometimes you will be doing the square root of something and they're going to ask you to round to a certain place value. So if I asked you to give me the square root of 156, we're going to use our calculator, and also notice that they will tell you what to round to. So for this one, we're going to round to the tenths place. Second square root, 156. We get 12.48996. So let's do 12.489. 12.489. Like if you're doing the test, you would write down the first few digits. If I'm rounding to the tenths place, I'm going to identify that the 4 is in the tenths place. The 8 is going to make the 4 round up. So when we round, this is going to become 12.5. Let's do one more similar to that, where we have to round. We're going to do the square root of 89. Hang on, my pen, there we go. Pen was taken just a moment. So if we're doing the square root of 89, and for this one, we're going to round to the hundredths. Sometimes they'll use a word, and then sometimes 2 decimal places, 3 decimal places. So you would just go with whatever they have as their direction there. So square root of 89, 9.43398, 9.43398. If we are rounding, as I said, to the hundredths, tenths, hundredths, the 3, so this is going to round to 9.43, which is 9 43/100. Last but not least, we're going to revisit, as I said, the Pythagorean theorem. The Pythagorean theorem relates to having a right triangle. The two sides that make the right triangle are A and B. The diagonal is the C. The A and B are also called the legs. The C is called the hypotenuse. Our formula is A squared plus B squared equals C squared. So if we have an example here that we're going to do, I'm going to choose one of those that you have in your workbook. They are giving us, okay, let's start with a simple one. They're going to give us, and they're going to tell you that the one leg is 5, and they're going to tell you that another leg is 12. So that means the A and the B are 5 and 12. So that would be 5 squared, 12 squared equals C squared. Use our calculator. So we're going to have 5 squared plus 12 squared. That will give us 169. So 169 is equal to C squared. Our objective is to solve for C, so we're going to have the square root of both sides. And when I take the square root of 169, we will get 13. That one's even, 13 even. Okay, let's do one more. This one I'm going to sketch a drawing here, a ladder that's going to be leaning against the wall. So here, the ladder is 11 meters. The distance at the bottom is 4, and we do not know the side. These are the A and the B. Okay, so I would have 4 squared plus x squared equals 11 squared. So 4 squared gives us 16. 11 squared gives us 121. So I would have 16 plus x squared equals 121. Now we need to get this variable by itself, so I'm going to take that 16, I'm going to subtract it to make it cancel on this side and move it to the other. So I now have x squared equals 121 minus 16 is going to leave us with 105. As we're trying to get our solution of x, we need to take the square root of both sides so that x will now be alone. So the square root of 105, I'm going to get 10.2469, 10.9. Now, when I look at the problem and I read carefully, it tells me that they want us to round the answer to the nearest tenth. The 2 is in the tenths place. I look at the digit beside. So this is going to round and become 10.2, 10 and 2/10. The 4 makes the 2 stay the same. And that, ladies and gentlemen, is sections 11, 12, 13, and we will work on sections 14 and 15 on our next class period.